Hi, my name is Duncan, and today I'm going to be talking to you about how to self-host large language models with the Axon framework. Axon is an RPC framework. That means it can invoke code on other machines across a network using syntax very similar to normal local function calls. In doing so, it transmits parameters to a worker, which will run the code on those parameters and then send the result back to the client over the network. Axon allows requests to flow through not only local area networks, but also through third parties on the internet called reflectors. Workers can establish connections to reflectors ahead of being invoked, and this allows for devices to self host without opening a port on their network. Now, on to large language models. Large language models really are the technology of the day. They're changing what people thought was possible with technology. Stable Diffusion, ChatGPT, and Sora are all LLMs, and they can generate images, music, poems, you name it. LLMs, unfortunately, have a very large resource footprint and so can't be run on most devices. They need a strong GPU with lots of memory in order to run efficiently. And so, usually using LLMs comes with the added challenge of using a distributed deployment to actually invoke these models. You can find a lot of LLMs for free on Hugging Face. This page is for a stable diffusion model. And here's me running it locally on some prompts and then looking at the images it generates. I also chose to use a text generation LLM for this demo called BlenderBot. And the Hugging Face page for it wasn't very good, so I had to use this Medium article, but I got it running locally, and here we are running some prompts through it. If you'll remember from earlier, in order to invoke this LLM from outside of my own local area net, I need a third party at a public IP address to route requests through. And I've chosen to use a DigitalOcean droplet costing only $4 a month for this. Let's start altering our Stable Diffusion script to serve Stable Diffusion worldwide using Axon. The first thing we need to do is install Axon, and that can be done with pip from the command line, just like any other Python project. And then once we've done that, we can go into our script, and I'm going to take out that breakpoint I used for the other demo. And first thing we need to do is import Axon, and then we create an object called an ITL worker. And this connects to the reflector and takes requests on behalf of this worker. The next thing we do is we define a function using that worker instance. And this function actually interacts with the Stable Diffusion pipeline. It runs the prompt that it gets fed, and then it returns the resulting image. And we could call this function whatever we wanted. We don't need to call it run prompt. We could call it gen image if we wanted to. And then the last line is telling the server to stop evaluating and wait and listen for requests from worker. So now when we run this script, it should load Stable Diffusion and then pause once it starts listening. And we should be able to access this from another process. So on the client script, we need to import Axon as well. And then to access the service, we create what's called a stub object. And we've got to pass in the IP address of the reflector because that's where the service is. And then it'll serve our Stable Diffusion at reflected services. So now we should find a attribute on the stub object matching the name of the worker. So it should be called stable diff. And then on the RPC property of that, we should find our RPC here, gen image. Yep, we see that. And now when we run a prompt, like this is async, so we got to add the join. When we run a prompt on it, we should find that Stable Diffusion returns a pill image. And here we are. Now let's do the same for BlenderBot. You can see here I have the code to import all the libraries we need, load up the BlenderBot model, and then also to actually give it a context to draw information from. I've also already defined a function to take a string input, tokenize it, feed it through the model, and return the outputs. So all we need to do is remove the breakpoint, import Axon, and then define a worker object, much like we did with the last example using the URL of the reflector. And then since we already defined the run prompt function, we don't need to do that here. We just got to pass it into the Axon RPC function and then call Axon init to wait and listen for incoming requests. Now, to access this stub, first we got to start the script. First, we got to import Axon, and then we create a stub object much the same way. And then our worker isn't called stable diff anymore. It's called BlenderBot. So that should be the attribute you see here. And then on the RPC, should have a run prompt function. So when we ask it, what do cows eat? It should say that. Let's take a minute to review what's happened. The system we've created can be represented in this diagram, where a reflector at a public IP address is taking requests and passing them down to our local machine through a connection that our local machine established. And that means that the services we're offering can be accessed from around the world, but we don't need to open a port on our network and deal with the traffic from the open internet. Also, something that's important to note is that the actual hard matrix math computations that comprise these models, Stable Diffusion and BlenderBot, are running locally on my desktop PC that contains a big, strong GPU that can handle those computations. The reflector can be very lean. If you can remember, I used a DigitalOcean droplet that only costed $4 and had a single CPU core because it's not actually supporting any computations. It's just passing messages down to our own machine. That's all for this video. Thank you for watching, and I hope Axon can be a useful tool for you now or in the future.